My name's Alan Jones, so I operate a BMS consultancy, Fairlawn Controls. Been running this for about 20, 25 years. Background of M&E design, never really been a BMS specialist or worked for a BMS contractor, so I'm not biased by anybody's ideas, just my own ideas. And I just really enjoy it. It's just sort of job that you just keep going at, isn't it? Keeping it simple, because there are lots of solutions, but in the end it's a simple, the only purpose for our BMS is to say the room is cold, the room is warm, heat it or cool it.
Absolutely.
And that in the end is all you're trying to do.
Sure.
Now you can have some very sophisticated apps, some very sophisticated wall sensors, some very sophisticated, whatever you want, but in the end all you do is try to get a warm.
Yeah.
And rooms don't change that quickly, you know. Half an hour for a room to change. So a BMS doesn't have to act very fast.
Sure.
So sometimes when people say, well, let's have a DDC controller that does it very quickly, well, what's the point? And that's one of the dangers of a BMS these days, is that it's gone in two ways. It should be a simple system, but now it's becoming extremely complex because, as you quite rightly say, there are so many different solutions. And the BMS person is being dragged from simple solutions into the much bigger complex solution of trying to stick together all these third-party ideas. And that's real complicated, because an M&E contractor very often will say, I am definitely going to use a chiller from XYZ. I'm going to use an air handling plant from these people. And some of this kit come with inbuilt controls on them, which the cost of the controls is lost in the cost of the machine. So the BMS man is now becoming a stitch together, an integrator.
Sure.
But writing a BMS spec is very hard to, if I was to write a BMS spec around a chiller and then suddenly they buy another one because the main contractor says it's cheaper or more efficient, and that's what he does. And now whatever control I wrote around A won't work on B, so I've got to write something that's a bit more generic. If I could be confident that they were definitely going to buy this chiller and definitely buy that boiler, then I could definitely write a control specification to join it, but it's impossible.
Yeah, sure.
And I've got to assume that people who are BMS specialists are going to be able to twist around it a little bit. So as long as I give you some rules and regulations that says these are the things I want, and you've priced it, whether you've done pounds per point or engineered it, however you've done it, you've got a lump of money to solve a project. And all I'm trying to do in a BMS specification is to take away as much risk so that you've got more certainty. So the bit of uncertainty is not too big and you can manage that. But then, because you've got certainty and cost, when the contractor changes something, you know exactly where you've got to change. Sure. You're not cherry picking something from somewhere else. So it is tricky. And I write a BMS specification, never mention anybody's name, because I think you can all do the same. Some clients want a particular supplier for whatever reasons, but in the end, they'll all do the same.
Sure, sure.
So BMS has got its fingers everywhere, because without the BMS, all these other disparate systems are never going to work. And you'll spend all your life putting them right. Bit more cooperation between people, less confrontational, and people admitting that perhaps they've made a mistake. You know, there's nothing worse than a contractor saying, I want to buy this piece of kit, but I specified another piece of kit. And subsequently I've discovered that perhaps the bit of kit I specified wasn't quite right for whatever reason, and I want to change. And they're unable to change. They feel as if they're up against a brick wall. And you think, well, just change. Yeah, sure. Just admit you're wrong. It's not an admission of guilt. It's not an admission of error. It's just designs have developed. Things have changed, and change it. And take away that issue. And if you take those issues away, that cooperation, everything is easier. Sure. they're almost to the point of thinking, I don't want to be seen shown up, but they're not being shown up. If they said, let's change, nobody's going to criticise them. Nobody's ever criticised anybody for changing their mind.
Sure.
After all, we've never really made a mistake in engineering. We might not be perfect at every job, but we get the jobs done, you get the jobs finished. You know, I always, it's an analogy of when you're at school, if you get an O level, you need 40%. You get an A level, you need 60%, you're doing really well. You get a degree, you got 80%, you're doing really well. You get to work, unless you get 100%, then you're a failure. And you think, well, how can that be? Because at 80%, I was brilliant, I got a first.
Sure.
But at work, I didn't get 100%, I failed. And that's really unfair. But people are scared. But the man who runs the job, he goes to Sainsbury's on a Saturday morning, as everybody else.
Yeah.
He's not God, is he?
No, absolutely.
He might shout at them, but so what? Well, apart from the simple fact it's gone from analog controllers to DDC, that's one thing. A lot of other things haven't changed. Jobs are just as complicated. The biggest change has been time. Jobs now take half the amount of time that they did 25 years ago. And
what's driving that?
What's driving that? I don't know, money, I suppose. And probably an increase in the way that buildings can be built.
Mm-hmm.
You know, we don't build concrete buildings anymore that we used to build 30 years ago. It's all steel frame. So it's up quick.
Mm-hmm.
And if it's up quick, the developer wants his money quick. So he lets the building quick. So everybody has to move quick. Which may be one of the reasons why people don't have time to think anymore. But that's the biggest change, the time. In the BMS, obviously, we've had, as I say, DDC controllers. Now we're moving into smart apps and into cloud and into energy management and automatic controls. I mean, I actually think that BMS was the wrong name. About 35 years ago, when BMS's or automatic controls companies decided to change their name, became BMS people. They weren't actually doing building management. They were just still doing automatic controls for HVAC, but they called themselves BMS people. And a lot of engineers, or a lot of people outside the industry, assumed they were now managing buildings. Well, they weren't, were they? And it's only, even now today, they're only beginning to scratch the surface of managing buildings. So they're beginning to change them, beginning to become what they were called.
Yeah, sure.
So we're now moving into energy management, asset management, people management, these things that do manage buildings. So it's only now that, in my view, a BMS person is actually beginning to become BMS. There is a challenge. The challenge to smart buildings. I mean, there's no doubt about it. Smart buildings are beginning to come the thing. Maybe not today, maybe not tomorrow, but definitely going to come. But it's got its own challenges. So first of all, what is a smart building? You know, nobody really has got a name for that yet. It breaks into two fields as far as I can see. You've got smart building intelligent people, and you've got smart management of offices. Mm-hmm. So you've got building management, you've got room monitoring systems, visitor systems, guidance systems, wayfinding. That's one smart. And the other smart is the HVAC services. And that's something that we're more interested in and more we can do with, so we can start getting smart about managing plant, integrating it into computerised facilities management systems, something which we've spoken about for years but never really done.
Sure.
Energy management. Okay, we have energy monitoring, but nobody actually really does very much with it. There are a few enlightened companies that do, but most people just gather energy because it says in Part L that you have to do.
Oh.
The building regs say do it, so you do it, but I don't think anybody really manages it. And people don't manage it because when the BMS contract is finished and the building is finished, everybody washes their hands of it. And the contractors go off and start the next job. And any expertise that you've all got goes somewhere else.
Yeah.
And you end up with a group of facilities management team who are firefighting the fact that the toilets don't flush, or there's not enough coffee, or somebody's hot. They're not interested in the time to energy manage. So all those sort of things that we put in place are not ever being used.
Sure, sure.
Now, if you can get them out and get them into the cloud and get third parties to manage smart buildings for other people, then that'll be good.
Yeah, sure.
But you've got to pay for it.
Absolutely.
And people won't pay for it. You know, a developer doesn't want to pay for it because he's only going to build a building and sell it on. Somebody who's an end user might build this building, and then he's faced with 5 tenants who don't want smart. So now you've got this conflict of, I want to give you a smart environment, but you want to use your particular controls contractor for your floor because you've got a worldwide agreement with them. And well, can we integrate it? Well, yeah, I wish you could, but it's not that easy, is it? So this smart thing is going to have to be looked upon quite carefully about who is smart, who's running it, and who's going to manage it. So problems you see at the end of the jobs are generally jobs that are not finished. That's the main problem. Other problems of technical expertise, do they really fail at the end of the job? I think technical issues are solved. So most of the jobs at the end of the jobs, when they don't work, are because of some failing of communication somewhere on the line. A boiler's turned up with 4 terminals and you were expecting 5. Mm-hmm. Or a pump has turned up with senseless controls and you were expecting to control it. Now that's just to do with communication and workshops and things that never go on. At the end of all these things can be solved, but the challenge you face is that there is a date called practical completion. And at practical completion, everybody wants the job to be complete because they want their money. Now, a lot of things you can't complete in a BMS until after practical completion, right? So you can't complete loop tuning, you can't complete the operation of the plant, you can't make sure everything's working together because you haven't had the time. And that can only take place afterwards. But unfortunately, at PC, you get this issue and everybody finishes and everybody goes. And so you're left with these myriad of problems that you can't solve. So you go to the next job and somebody says, oh, the last job, they never got that finished. Well, they didn't get it finished. No, they didn't get it finished. And everyone knows they didn't get it finished because they weren't given the time. So you've got this issue, you need something you need after commissioning, soft landings, call it whatever you want. I did have one job one time many years ago where they had a separate contract for commissioning, and it was a really good idea. So we built the whole building, and then we were going to commission it afterwards. Everything, water, air, electrics, the whole lot. That was the plan. The failing was this consultant was a European consultant, and the job was being built in the UK, and the UK management side could not grasp this idea that you did commissioning afterwards. So the job had to be finished. But it was a real shame because it really was an idea, was to do commissioning as a completely separate package afterwards. There was a risk maybe that he'd find something, but that was sort of the way it was. And there was a completely separate lump of money to do it. But it got taken away. And you still got this challenge today, that unless you can, at the day of completion, practical completion, somebody wants their money and somebody needs to be able to justify that they can pay their money. And if you've got a BMS that isn't complete, then there's an excuse for lots of people to say, well, we haven't got to pay you. But we know we can't finish on time because we've not had the time, we've not had the wherewithal beforehand, we've not had the right information. So it's tricky finishing a job. And because the BMS is always at the end, you can't get any more time. Okay, as I go back to earlier on, people need to talk to each other and people need to admit that they're wrong and can make changes. Because technology, it's easy, isn't it? I mean, you can control a boiler, you can control a chiller. You know, if I go to a software test, I'm not really interested in can you make a valve go up and down if it's hot or cold, because I expect you to do that. I'm more bothered about what happens if the sensor fails. What happens if I throw an outside air temperature fault in at the same time as I got a frost condition, or they're the more complicated things. And unless you do those things, you're never going to get a job finished. So you need to communicate. Now, if a contractor says, I'm going to buy a particular boiler that's slightly different to the one he's bought, that's specified, well, a bit of give and take, you can make these things work. But there are specifications and there are people who will pick a piece of paper up and want to go down line by line and say, you haven't done this, you haven't done that. Well, that's no good for anybody. You know, we all need to work together. We're just normal human beings in normal human life. You know, we make mistakes, we've got ideas, we changed our mind. Because I have projects sometimes where they say to me, can I go in and have a look at this project? Well, I don't know anything about the job. So how can I, in 4 hours, work out whether a job's right or wrong? So I just turn up with a set of key deliverables, you know, even simple things like, is the plant room clean and tidy? Because if it is clean and tidy, then I've got a good idea that care's been taken. If I go into the offices and I can see sensors in reasonable location, I think, well, some thought's been put into it. Running the plant, well, I know you can make the plant work because that's what you do. But it's more, do I feel the job is right? That's how you got to look at a job. And if you take that to a job and said, well, I've turned up, do I feel this job's right? The chances are it's going to be right. There will be underlying things. There will be things wrong with it, but nobody's going to criticise that.
No, sure.
So you've got to be much more flexible about when it comes to giving practical completion or snagging or criticising. You've got to be flexible, and some people can't be flexible. Sure. And maybe they're not flexible because they don't understand it. I don't think that's true because it's not complex. I'm not asking someone to understand software. I'm just asking to say, does the building do what I think it should do?
Sure.
And if it does, move on. You know, it begins from the beginning. The developer decides to build a building. He just needs to go to a group of people, professionals, he's called quantity surveyors, who say to him, well, this building is going to cost you £185 million, of which £100 million is your services. Now, he's got no idea in that £100 million how much the BMS is, or how much the controls are, or how much the lighting is. It's just £100 million. And then as you go on, you can develop this, and then you'll get this, well, it's too expensive, and value engineering and all these sorts of things. And then you can bring everybody in, but you can't have everybody all at the same time because you'll never solve everything. On the other hand, as a building services engineers, perhaps they need to be not frightened of BMSs. There's still this fear somehow a BMS is a black box. It is not a black box. It is not. They just need to realise that it's simple. If only they can write down a piece of paper how they want an air handling plant to work. That's all a controls person needs to know.
Yeah.
From then on, they can forget it. But asking some consultants to write on a piece of paper how an air handling plant is supposed to work, they can't write it down. Some of them can't even draw a psychometric chart, which is a bit concerning. But that's all you need. You just need them to write down 4 lines on a piece of paper. This air handling plant is a constant volume, variable temperature system. That's all they've got to write. Let the people like you and I then add the meat to the bones. What happens if this fails? What happens if that fails? This is how an optimizer is going to work. We'll add those details in. So people just need to put the small bits in, and then people add the meat onto the bones. But some people aren't even incapable of putting the small bits on. And there's this sort of, well, you're the expert, BMS people, can't you control the plant? And so you ask the question about, well, what should I do? You're the designer. I don't even understand what you want to tell me.
Sure.
And immediately you've got a conflict. With one saying you're the expert, the other saying I don't understand.
Yeah.
And unless you can break those sort of cycles, you don't move forward. But just getting simple words out of simple people is not easy. You think it is, isn't it? You think you could say, how does this fan coil work? You know, and then you go to the other extreme, and you get a pressurisation unit that's got Modbus on it. And what do you want Modbus on a pressurisation unit for? But the good man from the pressurisation people has got into the contractor and he sold this great idea of Modbus. So he puts it in his mechanical spec, and I can't work out what he wants it for. I've got a high pressure, a low pressure, and a common fault. Why do I want Modbus? Why do I want complicated? I can't even make my simple fan coil work, and now I've got what used to be an F&E tank has now ended up being a complicated Modbus bit of kit. So you've got all these influences on contractors and consultants. You've got the client saying save money, the client saying I want everything but don't send any more money, the mechanical contractor trying to get his favourite people involved in it. We're all on the outside trying to get a piece of the action. No wonder the jobs are complicated, you know. But we've done a lot of jobs over the years, and in essence, most of them worked.
Sure.
Yeah, there's been some problems at the end, but nothing serious, is there?
No, sure.
You know, how many people have died because the BMS didn't work properly? You know, you go back to the days of the millennium. Crikey, you thought the world was going to end. 1999 to 2000, my word, there were people rushing around the country making oodles of money, changing chips, but what's going to happen the next day? What could be the worst that could happen? The heating wouldn't come on. Yeah. But everybody got completely bamboozled by it. And those things are still in the BMS systems. And I can guarantee you can probably find a BMS spec still that says make sure your BMS is 2000 compliant. So you can write specifications in two ways. You can write a whole job specification on a piece of paper. Please build me 100,000 square feet of office block for general office staff, and I want a room temperature of 21 degrees C, and that's what I want. And get on and build it. So that's one way of writing it. The other way of writing it is you end up with thousands and thousands of pages of paperwork that nobody ever reads. So somewhere between the two is where you write a specification. Now the easy thing to do apparently is to copy and paste. But people, who often reads a specification? I don't know people who read specifications. You know, most people don't. Most contractors get a big pile of specifications. They used to get CDs, they used to get papers, then CDs, now they get a web link. And on that web link are about 5,000 documents of which they can't even work out what they are because it's just got a number, doesn't say what it is, so you have to open up every document, spend a lot of time, a lot of money. And when you find the document, you don't understand it. And then you just look at the job and you say, well, it's an office block. The last one I did was £200,000, so this one must be £200,000. And almost, I'm not being disrespectful slightly here to contractors, but almost you've got to have some way of benchmarking a cost, haven't you? So it's a big job, or I don't like this contractor, or I know he's hard work. And that's how you do it. So the person writing the specification, they get away with it because nobody reads it. And they only read it at the end when there's a problem. So there becomes a problem on the job, whether it's the controls or the boilers, doesn't matter what it is. So the next job that goes out, you can be sure that there'll be a big paragraph about the problem and making sure it doesn't happen again. But that problem won't happen again anyway. There'll be something else. So cutting and pasting specifications is easy for a contractor or for a consultant. I obviously work for myself, so I charge money to consultants. And I try to get business from consultants. And their view to me is, well, really interesting, really good idea, but I can get it for free. I can go to a controls company and they'll give me a free specification. So I say, well, that's fine, but then you'll be using their specification and their job. And they go, yeah, but that's fine because I haven't got a problem, have I? I've mitigated my risk. I've got rid of it. I've given it to the BMS contractor. He's written the specification. He's put it in. I'll sign it off. So what risk have I got? I've moved away from my risk. So then you ask him questions like, well, that means you're tied into this contractor. And supposing the main contractor decides to use somebody else because they haven't got to use what you tell him. Now what do? Now you're faced with the problem of you've got a specification written you don't actually understand because you didn't write it. So when the third party comes along and asks you a question about it, now what do? Their general answer is the tech sub goes back, status A, to be confirmed as written in the specification. So they don't want to get involved. It's easy for them to pass the responsibility and the remit to somebody else. And so they write a specification. If they're going to write a specification properly or to the best, then they've got to spend time and money. And they don't want to spend time and money. They don't have the time and money to spend. So it's really hard. You know, I've got 2 or 3 consultants, contractors I work for, and perhaps they're enlightened. Perhaps they realise the benefit of paying someone to write a specification for them. But it's really hard to get other people to do it. And it's easy for them just to cut and paste. And until, well, I don't think anything's ever going to go wrong. People are never going to change cut and paste. Why should they? Because it's easy. And as people go up through the industry, through their company, the junior sees the senior cutting and pasting, so he just does it. The client doesn't need, because the client just wants a building built. So he's not too concerned about the detail. He employs specialists to do his detail. So he doesn't want to know too much about his detail. If he's going to run the building, he might be more interested in how am I going to run my building, what information do I need to run my building, and how can I make that more efficient. But he's not too bothered about it because he's got his £185 million building. He doesn't really mind too much how it spends. The consultant, educate the consultant, yeah, it could do. Just feed a bit more information to him. Get him to provide simple rules, just simple ideas about how his plans to work. That's all you need from him. The main contractor, that's tricky because the main contractor is a big player. He's a big player. He's got a lot of cash flowing through his company. Could well be bigger than the developer, you know? So he's got a lot of cash. Now he's got a lot of influence. And he will have 5 or 10 companies on some sort of framework with him, some sort of partnership with him. But he still wants to deliver a profit, and his shareholders still want a profit. And so you can try and educate him a bit. And then you come down the line to all these other people, the mechanical contractor. But truly, in the end, why do we need to educate them? Because who wants an easier life? It's not that difficult. We know it's frustrating. We know it's tricky, but it's not difficult. And we only want education if things go badly wrong. And people don't go back if it's badly wrong. Nobody ever goes back to a job. Very few consultants and very few. The only person who goes back to a job is the contractor, and he gets called back that it's failed. The consultant never goes back to find out the goods or the bads. The main contractor never goes back except to paint the walls that he forgot to paint. And the builder and the developer sold it anyway. So you've got this issue of when the job is finished, who wants to know about it? And there have been issues, but nobody wants to know. And if you could influence people to be more friendly, that would be solve most problems. take away the conflict. I don't think you don't need to educate people about how a boiler works or a chiller works. Just get people to be a bit more open about things, and then life would be easier. We don't get up in the morning wanting to have an argument, but there is just some people in this world who are like that. I'm sure we would end up smart, we'll end up IoT, we'll end up in the cloud. Who knows what it means? I've got no idea what it means. I think it just means that your controller you've still got a controller, but the information's somewhere else. I don't think you're going to end up with a controller in the cloud, or perhaps you are. Perhaps you're just going to send sensor values and valve values to the cloud and it come back. Maybe. You become quite reliant upon the cloud at that point in time. You know, we still write specification with a hardwired interlock for a pressurisation unit. So are we going to be brave enough to drop all that and just assume it's in the cloud? Every day people use the internet, every day people use apps. So they're becoming much more comfortable. But the day your internet drops out, people panic. I can't get my bank account, I can't do this, I can't do that, I can't. So perhaps if my internet drops out, how do I control my building? So controls disappearing from a building to a cloud, probably not. I think you'll still have controls in the building. What will be up in the cloud is all the data, all the analytical data, and perhaps access for third-party specialists, which we've always had. We've had remote bureaus for donkey's years. Not sure people really realise they're remote bureaus. There's still this sort of mystique about, well, shall we connect it to the internet, or shall we have a dial-in line or something? I think, well, we've been doing it for 25 years or 30 years, and now suddenly it's all become difficult. But it'll end up some sort of cloud-based control system, possibly. Whether that cloud is somewhere else, I mean, that cloud could still be within the building. It could be a virtual machine living within the building. So at Gatwick Airport, for instance, we've got virtual control systems. But they're in the building. They're within the Gatwick environment. They're not held in California or somewhere. But I think most of it will just be the analytical data. The controls will still be there, because eventually you still need that controller to control the local air handling plant. Whether that's a packaged air handling plant with a package control on it, or a bulk controller that controls it. I don't think it'll end up all remote, because it needs to be managed, and somebody wants to sell it. You've got a box. Within this box is all my building. I can't sell it if something's over there. Sure. So I'm going to buy this box. Otherwise, it's a bit like these third-party building metering specialists who take the metering off site and somehow magically give you back data. Well, they're outside your environment. BMS could do just what the service they're doing, but you've taken this package of tenant billing, energy management, and given it to a third party somewhere else. So when you sell your building, you're selling something somewhere else as well, which maybe somebody doesn't want to buy, but they might have to buy it because you're sort of tied into this thing.
Sure.
Well, that's an interesting thought. Okay, so you've got packaged controllers, for instance. Okay, so similar idea. I'll go and buy an app called an air handling plant controller. I'll go and buy an app called a boiler controller or a chiller controller, which is great. And there is an argument that says the app for the chiller controller is perfect because it's written by the chiller man. So good idea. The control system app for the air handling plant is perfect because it's written by the air handling plant man who knows much more about his air handling plant than some controls engineer. That's fine. Unfortunately, there's only, within a big organisation of a chiller manufacturer or an air handling plant manufacturer, lots of people know about air handling plants, but there's only 3 blokes know about the control system. And you want those blokes on your site now, not tomorrow, not next week, now. Now, unless that chap can come, you could be faced with a situation of a controller you can't get to work. So what does the main contractor do? He turns to his BMS man and says, "His controls, go and sort it out." And you're going to have to sort it out because nobody else is going to do it. So you've got these small groups of people who are being pulled all over the country doing these packaged control systems, but not to your job. They've gone somewhere else. Now, as a BMS contractor, you make your money through bulk buying of valves and bulk buying of controllers and things. So some profit is in that and some profit is in your engineering. But if someone takes away from you that bulk valves, actuators, controllers for air handling plants, where does your profit start to come from? You start to become like a consultant and all you're doing is selling expertise. And expertise is expensive. And expertise to a third party or to a contractor is like, well, why am I paying money for expertise? I can get that from the air handling plant for free. A bit like me trying to sell specifications to people. Why am I paying a person to write a specification when I can get it for free? And what's going to happen is that all these jobs are suddenly going to just grind to a halt because there are nobody available to do it. So you've got people who might be the right apps and join them all together, but there might be 5,000 of them working in California, I don't know, but there's 50 million people in the UK. You know, there's not enough to support us. So some people will make massive amount of money because they'll be the right person at the right time, but everybody else is going to suffer.
Yeah.
So if we're not careful, we're going to end up in this technology age of brilliance, but reliant upon very few people.
Sure.
And down the bottom here, everybody else doesn't know what to do anymore. So we could be going back to basics of, let's put a thermostatic rad valve on. Why do I need my control system that talks to Honeywell via America to open my valve up? Can't I just put a thermostatic rad valve on and make it work properly? I mean, you say about people losing skills. I mean, you're right, but ever since I've been working, people are using skills.
Sure.
You know, we've had skill shortages and apprenticeship schemes used to be apprenticeship schemes, and now they're not anymore. There are no apprentices, so they had a few apprentices last year, didn't they? And then they all died a death. So this training and things like that have disappeared. But we're still here, 50 years later, 100 years later, still doing engineering.
Sure.
So it hasn't actually disappeared. It might have gone somewhere else, but it hasn't disappeared. Go right back to what I said earlier on. If you're not careful, you've lost engineering skills. You know, how many jobs have you seen where you've looked at the pipework and you think, well, the pipework just isn't being put in correctly. And I can write as many apps and control systems as you want. You can't put it right if the pipework is back to front. You know, simple things like a low loss header is so important.
Sure.
Simple things like having pump sets that control are so important. Oh, well, let's take the pump sets out, save money. Let's take the low loss header. We can't get the pipework in, take it out. Well, you can write as many apps as you want. You won't be able to solve it. So you can't lose this basic knowledge of Bernoulli's theorem and things like that just because I can write an app. In a home, one thing about a home is that people are quite happy to spend money for some reason. You know, they will go out and spend £5,000 on a mixer or £2,000 on a mixer or something. But in an office environment, they want to save every penny. You know, they leave home in the morning and they get to an office and their attitude about spending money completely changes. They don't ever want to spend money. And yet when their wife says, can I have a new mixer or can I have a new dress or can I have a new this, that or the other, it's spent, isn't it? But when you go to work, you don't. You don't want to spend money. So in your home, and your home is sort of manageable by yourself, so your network fails. You're a bit frustrated because my heating doesn't come on. But you sort of cope with it. Privately, you cope with it. But if you've got a big organisation of 5,000 people in an office, and 5,000 people now can't get their heating to work, and I'm only 3 people in an FM team, well, what do I do? Where do I go? Perhaps I go back to simple technology. I don't think it happens very often. You know, examples of things like power failures in buildings. Now, years ago, we used to worry about power failures and we worry about loss of power and standby generators. Well, how often do you ever hear of a power failure anymore? You know, it doesn't happen. So people don't now put standby generators in. Okay, if you've got a data center or something, your concern might be higher, but most buildings they don't. It's a life safety generator. You don't get power failures. And how often do they lose water pressure? You know, things like that. Those things have improved so dramatically. You know, fire systems. You get disastrous fires occasionally, but very rarely get fires in office blocks. You've got fire detection systems, sprinklers, all these sorts of things. So the good basics need to be there.
Absolutely. You
can stick your technology on the end of it, but unless you've got good basics, you won't. And if you're reliant upon half a dozen people, it's tricky. the outlook, I think it's a tremendous growth in IoT, tremendous growth in making things packaged, unfortunately. I think there's going to be a much more idea of packaged controllers. So a BMS contractor is going to have to become a real integrator now. You've got to realise that he's going to have to understand how these packaged plant do work. Conversely, these packaged plant controllers are pretty simple. They're not complicated. You've got to get away from the idea of licenses, so that you've got to be able to access these controllers. You know, the supplier's got to give people access. You can't have this protection of you can't have a license. So that's one way it's going. Whether you start to go towards power over Ethernet for controllers, I'm not sure we can do that really, but maybe that's where it's going to go. Wireless systems, I'm not sure that wireless systems are going to work all that well. I think in a building where you've got a plant room and a control panel, you might as well still stick to cables. Can't work out whether a wireless system is useful. Wireless sensors in offices are probably very useful, but you need a network and a mesh and all that sort of things to make it work. Maybe the BMS contractor stops doing MCCs or power wiring and gives that to somebody else. But that is bulk money, I guess. You know, it's easy cash, easy profit, which does pay for these things that he has to resolve that he can't cost for. If he says to a client, well, I'm going to charge you £35,000 for understanding how your air handling plants work and trying to join it all together, he gets a no, doesn't he? But if he's got that sort of money available in his fan calls. I mean, I think fan calls is something which really frustrates me, that a fan call is something which traditionally you've always done for £500 a fan call unit, thereabouts, and now you're not doing it at all because they're coming from somewhere else. But in that money, you had enough cash to pay for a network and pay for some graphics and all these other things and to get the job to work. Now suddenly, fan calls are coming from a third party with all the controllers on them, and nobody's looking after them. So, but I still think it's going to be packaged. I'm sure that it's going to be packaged because you can buy the controller on the packaged bit of kit, apparently, cheaper than you can buy a separate control system. So BMS companies are really going to become integrators, smart integrators, got to move into that market, move into energy management, tenant billing, all these things, smart peripheral things of a building. That's where you're going to have to go. And traditional things, you're going to have to forget about.